All right, last section. 8.8 is on parametric equations. I switched to near one of the last problems to actually motivate this topic. A good way to motivate it. Before we're done, we're gonna answer this question. 3 golf balls are hit simultaneously into the air. From ground level. Not some elevated thing, but from the ground. At an angle, at 120 feet per second. They make angles. Of 25 degrees, 45 degrees. And 65 degrees with the ground. Which ball travels the farthest? Like. Not like following the trajectory, but like. You're hitting a golf ball, you wanna get some yards on it, like, let's say the hole is 400 yards away. You gotta smack it a few times to get there, the more ground you. If you can get there in 2 rather than 3, that's ideal. So which ball travels the farthest? Which ball travels the highest? And which ball hits the ground first? We're gonna be able to answer these questions by the end of the day. Doesn't have to be a golf ball, but. I think we've all seen golf on TV, whether it was, we've got to watch it for very long. I doubt many people have, but you know the idea, hit the fucking ball, chase it, hit it again, gotta get it in the hole. It's clear that the angle is gonna. Affect the outcome. And let's say we drew a little picture, and I'm gonna make the ground the x-axis. And height will make blue for the sky, green for the ground. Let's say our little ball is right here on some tee. And the ball is right there. And it's doing some shit like this. Where it's making an angle theta. Now we could solve the first 2 questions with just y and x alone. And using the angle. But figuring out when the ball hits the ground means we need to have an element of time in there, right? So this is affected by time. The ball's position. With respect to the tee. Which is effectively the origin on our graph. is dependent on time. Since it was hit. This is our x-axis and this is our y-axis. It means those positions are affected. X is really gonna be a function of time. Like where it is in terms of how far away along the ground it is. And then how high up in the air it is also a function of time. That makes sense? When we introduce a new variable like this. In this case, the t. We are parameterizing the equation. And they are called parametric equations. The new variable is called the parameter. So parametric or parameter and parameterize have an E after the T. Parametric does not. Just like meter, the word meter has M-E-T-E-R, but metric does not have an E between the T and the R. Same thing with parametric. That's, to do this is a complicated equation. We're gonna start with some more simple parametric equations. And then we'll upgrade to doing like the flight of something in under physics, under gravity. Okay, this sounds neat. I'm looking this shit up right now.
Yeah, it's the word, I like words, like they call it entomology or something like that. Random. I can't get it. Latin or something.
I'm sure it's Latin. Everything's fucking Latin. I don't know, where's meter come from? I know it's used everywhere in the world, but Latin is the derivative language for most languages. It's not the derivative language for all languages. So, who knows?
Something.
I'll get back to you, my friend is a fucking linguist, he speaks 10, he studies fucking language, like. He knows the words for all the different fucking sounds and shit that. Like the throat makes and. Some of them are like, what the fuck is that? It sounds like some fucking wicked monster. He's like, no, it says oh sound or shit like that. Any questions so far, Patrick?
Nope.
So let's start with something different and we'll go back to that. Cause that's not a basic one. In fact, you'll learn this if you take physics 55. Or was it physics 20? If you plan on taking physics and engineering, don't take physics 20. Physics 20 is for people that aren't going into physics or engineering. It's the algebra approach to physics. And if you're gonna take calculus, you'll learn how physics really works rather than just. Physics 20 is like memorizing all the equations and like then you got a lot of shit to remember. Physics 55 is like, how does the equations connect each other? You only really need to know one, you can get the rest. Because you know the mathematics behind it. Let's say we have x as a function of time. Y is a different function of time, so we're gonna give it a different letter. We're gonna say x equals t squared minus 1 and y equals t minus 2. And we're gonna go from t starts at -3 and ends at 3. This here is the time interval. The start and the stop. Let's figure out what those values are. What is x and y when t is each of those values? Let's just go with whole numbers here. Let's do all the whole numbers in between. Or all the integer numbers in between. So like if I do t at -3, I'm gonna do the work over here on the side just to show a little bit. X equals -3 squared minus 1. And y equals -3 minus 2. And I'm putting the t in parentheses. Because it should go in parentheses, if it has an exponent on or anything out like that, or a negative sign in front of it, it really affects it. -3 squared is 9, not -9, 9. Minus 1, and so x is gonna equal 8. Y equals -3 minus 2 is -5. Take a moment, figure out the rest. Use your calculator if you want. When you took algebra or took like beginning algebra in high school or something like that. You had to see something where you make a little x and y chart, you plug in x and you find out what y is. Well, now we're plugging in t and finding out what x and y are. Brother-in-law is a very firm supporter of Trump still. And he likes to entice it. He was over doing our lawn today, doing stuff around the house. And he likes to joke, or he knows I don't like Trump, so he likes to like provoke me. Like, I mean, he's like, he thought I was gonna take a nap before I came into class, he's like, I'm gonna go in there and put like. MAGA on your head, or put a MAGA hat on your head, or do something. And then I was leaving, getting ready to leave, he's still there, he's out working on the front yard. And he's like, you and Trump have a lot more in common than you think. I'm like, you're right. We're both old white men. We like to hear ourselves talk. We both think we're fantastic and more people should be like us. And we're both leaving our marks on the world. That's about where the relationship or the comparison ends. Alright, pull out of that way.
Oh, no, you got the shirt.
Oh, yeah. Patrick's missing it.
No, you're wearing the shirt the one day I don't go.
Yeah. I'll try. I don't know if I'm in the picture very well. You're not responding. You probably can't see me.
No,
I'll
I
show you a
keep,
break time.
I saw. I just keep accidentally muting myself. But yes, I saw, and I was saying I saw, and then I was like, oh shit, I'm muted. I'm
It
new to
says
Zoom.
rough fractions on there. It's got my rate my professor score as of the time this card was made. We did this weekend. It was at Friday Night Labs. Some of you I've been trying to tell you to go to if you're gonna be engineers and stuff like that. Good spot to go to. They have a sticker machine where you learn how to like do all the tech work behind it, but we got iron-on paper to go with it. And not paper, this was like, apparently iron-ons come in two different, like, well, multiple different varieties, but the basic ones are for white colored background t-shirts or like basically any other colored background t-shirts. And the way they work is different. The white one, if you ever use an old iron-on, you take the image, you put the image against the t-shirt. You iron on through the image and it like presses into the paper and like sticks to the paper. It like kind of embeds the ink in the image. The other ones, the dark colored background does not, it's like a vinyl thing that you peel off. Then you put this like Teflon paper over it and you iron on over it, but the picture is face up. And like the heat makes the vinyl stick to the fabric and it actually keeps the color a lot better. We made one with the, like the white one first and like the colors just don't show very well. We even had, we had it on a gray shirt, we didn't have it on a white shirt, we thought the gray was like, is light gray. But we did this and. The retiring engineering teacher, asshat that he is. Filmed me doing the ironing so that he could report to my wife that I know how to iron whether I say so or not. Good times. He's retiring this year. Alright. Did you guys come up with the table? What's x and y for -2?
3,
Three,
-4.
negative
And -1
four. 0 and -2.
and 0
-1, -2.
and 1
0 and -1.
and 2.
From 1 over to me.
3, 0.
And I'm gonna guess this one is 8, 1.
Yes.
Okay. I notice that this is following a pattern, it should, because it's squared. Let's graph that. And see what it actually looks like. Looks like my x values go pretty high and my y values go pretty low. I should have made this look a little bit different. 3, 4, I'll make a bigger slash for 5. And 10. And we go above the x-axis. But we don't, and we even have a negative x, so I need to go backwards some too. It's y, this is x. 5, 10, 5, -5. -5, -10. Alright, when we were at 8, we were at, let's see if I can line this up right. -5 is right about there, 8, -5. And this was at timestamp t equals -3. And when t is -2, we were at 3 and -4. So I'll just say -2 there, put in parentheses. And then -1, we were at 0, and -3, we were right here. At time equals 0, we were at -1 and -2. Like, it looks like they were going like they were making bigger steps, but as we get more close to 0, the steps become smaller. And then we've got 0, -1. Oh, look like that, look at that, it's circling back around. So it's like we were doing this. But now it's doing some shit like that. And we've got 3, 0 puts us right there. So that's at timestamp 2. This was at 0. And 8, 1 is at timestamp 3. This actually looks like it's doing, what kind of shape would this be? Does anyone remember the name of the shape?
Probably.
It's a parabola, it's like a sideways parabola, right?
What was the base formula for the parabola, like?
But good. So like a parabola like this is like y equals x squared. A parabola like that is y equals -x squared. When it opens to the right, it tends to be x equals y squared. And if it opens to the left, x equals -y squared. And there might be some other shit affecting it. We tend to do x minus h squared plus k, where this curving point is called the vertex, is at hk. So when it's like in the y format, that's the same for both of those. Just the negative goes out front there. When it's in the x format, we do x equals y minus k squared plus h. And our vertex here was at timestamp 0. Our vertex is -1, -2. And since it's opening to the right positively, it looks like it might be that one. X equals y minus k is -2 squared, and then h is -1. So it looks like it might be y plus 2 squared plus or minus 1. Now, a parabola keeps going, the actual parabola would keep going, this one doesn't. That's important to know, this is just like a segment of parabola. What we did with since we restricted time, we have a segment of a parabola. I hope it's called segment. Segment is a portion of a line, I've never heard, we don't talk about portions of a parabola. But like a line segment is like a line that doesn't go on forever and ever. Let's see if we can get this equation, starting with this up here. Okay, how's that sound? Let's see if we can connect what the algebra says with what we had. And I'll rewrite the equations that we started with. We started with x equals t squared minus 1, and we had y equals t minus 2. So if you want to put them together. Solve one of these equations for t. And plug it into the other equation. And I'll show you both approaches and you'll decide for yourself which one you like more. So we're trying to see if we can come up with this equation right here. Let's solve this one first. Let's do x equals t squared minus 1. If I want to solve that for t, I have to add 1 to both sides. And I get x plus 1 equals t squared. And then I'll take the square root of both sides. And I get t equals plus or minus the square root of x plus 1. And then I started with y equals t minus 2. We're gonna take this and we're gonna plug it in up there. We're gonna get y equals plus or minus square root of x plus 1 minus 2. Well, that doesn't really look like this, does it? Is it the same thing now? I have this one solved for x and this one solved for y. Let's manipulate this one, do some algebra. Practice those algebra skills some of you are rusty on. If I want to solve to try to make these look the same, I need to make this solve for x here. To compare. So to do that, I'm trying to get x alone. I'm going to add 2 to both sides. I get y plus 2 equals plus or minus the square root of x plus 1. We're gonna square both sides to deal with the square root. And squaring it actually makes the plus or minus irrelevant. Because like 1 squared and is the same thing as -1 squared. So like squaring it takes away the signs. I get y plus 2 squared equals x plus 1. And if I solve for x, I gotta subtract 1 from both sides. I've got y plus 2 squared minus 1 equals x. Which is what we have up here. Because when you have two things equal, you can swap sides. We swap sides, I got the x on the left. I've got y plus 2 squared on the right, minus 1. Be careful swapping sides. With an inequality. Greater than or equal to, less than or equal to, less than. If you swap the sides, you gotta swap which way the mouth opens. It needs to keep chasing whatever, if it's a mouth, it needs to keep chasing whatever it was chasing before. That was a lot of work. What if we solve the other way? What if we started with y equals t minus 2? If I add 2 to both sides here. I get y plus 2 equals t. And we had x equals t squared minus 1. We're gonna take this. And drop it in there. In parentheses. And we got to the equation right away. Look at that, super fucking quick. Sometimes they call that graph. The graph in general is called a plane curve. And you're never gonna hear me say that again. At least not in that combination. Yeah, I use curve and I use plane a lot. But. You guys ready to do another one? For T, for T in 0 to 2 pi. X equals 4 cosine T. Y equals 2 sine T. Sons of bitches, a lot like those polar curves we just did in the last section. Right? We had to make a whole chart with angles.
Mm,
Let's just do the first half. And see if we can figure out what the rest of the graph is gonna look like. That symbol means in. Well, that's not the math jargon for it. The math jargon is an element of. But like, in general, that means T is somewhere between 0 and 2 pi. We often use T for the variable because time is often the component. Or a parameter. For motion. Where you are, how fast you're going, how quickly you're accelerating are dependent on how long it's been since you started hitting the gas pedal. You know anything about that counselor? So,
I was gonna tell you that the student success counselor said you were in sweats.
it goes what?
So,
Might send her an email myself. While you guys are setting up working on this. I'm fine making this table. Got a lot of this, say this shit sucks. Like you said, we weren't doing more back and forth curves. We're just doing this one so you can see kind of like where it relates to the parameter here. It's gotta connect to trig somehow, this is a trig class, not an algebra class. Let's see. I know those ones quickly, there's no hard math there. Ooh. Sine of pi over 6 is 1/2, which means that is a 1. And cosine of pi over 3 is 1/2, which means that's a 1/2 times 4 is a 2. And that's gonna make that a -2, and that's gonna make that a +1 down. Those are the ones that don't require square root signs.
I think the next one right is 2√3. So I,
And then 2√2. And these should go the other way. Uh, 2√2 and then 2√3. I need to put some fucking cross lines in here. Starting to misalign shit in my head. This is like 60 degrees, that's gonna be 2√3 again. 2√2, that's two, this will be -2√2. -2√3. And well, that shit ain't helpful. What's 2√2 or 2√3? I wanna put it on a picture, cause I gotta graph it, I don't know what the hell 2√2 is. This one is about 2.8. Which means that one's about 2.8. Which means that one's, wait, that one's about -2.8. And that's +2.8, and let's see what 2√3 is.
Would you lose the 2 on your right column, because it's, you have 4 cosine, but you only have 2 sine, yeah.
I would. I got hasty. Good catch. Gonna cut those in half. Excellent catch. This is 3.46. And if I cut that in half. 1.73. I wish I hadn't fucked up, because then I could have had the numbers not looking like shit. Looks like if I try to graph this. I need to be able to go out as far as +4 to the left and right. And as high as 2. Over 6 is 3.46, which is about halfway between 3 and 4 and up at the 1. 2.8 is pretty close to 3 and 1.4 is about halfway up, maybe right about there. That's pi over 4. Pi over 6. And we've got 2 and 1.73, which is right about there. And then we've got 0.2 at pi over 2. So far, we're doing some shit like this. And I should have done this last time and I didn't. It's handy to put an arrow on it to show the direction that. Going forward in time it's traveling. Then we go past it, we got, looks like this kind of mirrors over -2 and. -4, we 0, we have that. -3.46 was at -1. -2.8, 1.4 was right about there. And -2 and 1.73 is right about there. What do you think the other side does if we keep do pi through pi 2 pi? What kind of shape does it look like it's making?
An oval.
An oval. And in math jargon, we call that an ellipse. So and the way an ellipse works is it kind of is symmetrical over this. So I think the rest is doing that. Now, the general form for an ellipse. Let's see if we can get this to match up. The general form for an ellipse is x minus h squared over a squared. Plus y minus k squared over b squared. Equals 1. Where hk is the center of the ellipse. A is the length of the major axis, the longest part. And B is the length of the minor axis. Ah, fucking making me do more algebra that I didn't wanna fucking learn or study, that I haven't studied. Or it's been a long time since I studied, yeah, we're gonna throw away that shit in. The Calc 3 students today were working with this shit, and doing ellipses and going. Wow, ellipses are hard to work with, let's learn to do the mathematics to shift it to a circle, that's some bullshit. Go the full route, learn how to do shit easier. They were learning how blood flows through a vein today. We didn't mention blood flow through the vein, but we were talking about flow through the cylinder. Physics behind it. So like in this case, this is the major axis, the longest axis. And the minor axis is this. Which means in my picture, A equals 4. And B equals 2. The center, HK, is at 0, 0. Which means we should, if I plug those in, x minus 0 squared over 4 squared plus y minus 0 squared over 2 squared. I should get x squared over 16 plus y squared over 4 equals 1. So how can we go from x equals 4 cosine t and y equals 2 sine t? How do we get there? How does that turn into that? Any ideas?
I even, you can put 4 back into the T and then a double angle.
Is that gonna help us get over to here?
That's right. I'm guessing.
I think we could spend a while doing it and find that, but we might get there. But there's a much easier way to do it. And I don't wanna say no to it, cause it might work, but I think we might like waste the next hour trying to see if it does.
It's usually like how it works.
What does the left side have that we want? What does x and y look like on the left side? They're both squared, right? Let's try squaring, let's see what squaring does. If I square them, x squared is what? Well, we can square the whole thing. In case it doesn't jump out at you. And it probably will not until you've done this a few times. But more algebra, the square will delivers to both of them. Dan Jones, why are you doing this to me? So x squared is 16 cosine squared t. And y squared is 4 sine squared t. Any ideas from now that we got this, how can we get to this? By what? Divide by the coefficient, let's divide both sides by 16. On that one, we get x squared over 16 equals cosine squared t. And we get y squared over 4 equals sine squared t. Can we seal the deal?
Cosine squared plus sine squared is 1.
Cosine squared plus sine squared is 1, so let's take advantage of that. Let's add these two together. That's my cosine squared. And we'll add in the y squared. That should equal 1, which means those should equal 1. And we got it. That was the equation of what's going on. Alright, let's take a 10-minute break while you process that. Alright. Next idea. Let's look at how could we parameterize. How can we parameterize? Let's go, let's do the equation of a parabola, okay. Let's do a generic parabola. Problem in my notes, I'm not sure what. Dave is looking at has a specific example. But why do that? When we could do any parabola. How can we parameterize this with t? And is there more than one way? There is the lamest version ever. Don't do this. This is a shitty parabola. This is the worst choice. X equals t. So y equals t minus h squared plus k. I have now effectively made x and y functions of t, but like I didn't need to do that. The t doesn't help anywhere in this. I haven't helped any, I've made it worse. Really. By taking one equation, separating it into two, and it doesn't really help. Another way that's like the way we did, the way the previous problem did it. The previous problem had, what do we have? Let's go back to the very first thing here. We had x was t squared minus 1, which is kind of like. That's a little weird, where did they come up with that? They just let t equal the inside. So they let t equal the inside. So one way of doing it is t equals x minus h. So that y equals t squared plus k. Another way of doing it, we could say like t equals x minus h squared. And that makes y equal t plus k. Now. Just gonna do a quick little chart without plugging anything in and just pointing out which way is better here. If I do the top one, let's say option A up here. whatever I put in T goes in X. And then Y is just the full equation. Not all that helpful. I literally just added another column to the XY thing and haven't gained any ground. The middle one, the red one, we'll call B. If I go like T equals 0, 1, 2.
This meeting is being recorded.
Well, this might look a little bit better if I write X in terms of T. And saying X equals T plus H. So here I would have 0 plus H, I would have 1 plus H, I would have 2 plus H. And here I'm gonna have 0 squared plus K, 1 squared plus K, 2 squared plus K. And option C. Well, for C to be useful, I need to do what I did with B and write X in terms of T. If I wanna write X in terms of T, I gotta take the square root of T. And then I gotta add H. So let's look at some basic. Put an H there, that should be a Y. Got all fucking happy writing shit down. If I do 0, 1, and 2 here, this is. Square root of 0 plus H, square root of 1 plus H, square root of 2 plus H. And this is 0 plus H, 1 plus H, 2 plus H. Which of these looks like the easiest to actually work shit out if we had values for H and K?
B.
Why?
There's not a square root.
Okay, that's exactly it.
Yeah.
So like there are different ways to do it. Some ways are better, like here. I don't really, like if I said H was K were 0. Which is a lot of them, a lot of times we have HK 0. Doing this is just easy, X is 0, 1, 2. Y is 0, 1, 4. It's pretty easy. Here, well now I got fucking square root of 2 in here, what the? Plot graphing that's not easy, we had to graph the calculator previous. So like some methods have. Some methods produce easier shit to graph than others. Some methods or parameterizations, I should say. And while this isn't on your test, you will be doing, if you go into calculus, doing parameters at some point, and it doesn't take that long. When you start doing a parameter, if like the first way is like really hard, maybe pause. Grab a piece of scratch paper and go, is there a fucking better way? Cause like you might have picked the hard way. Next topic, I'm gonna introduce it, I'm gonna show you how it works, but we're not gonna do a problem, and you're gonna be thankful that I said this. The cycloid. Let's say you got a bike. That's your handlebars, there's your bike seat. The way the cycloid works is, let's say we put a little bit, like a point on the wheel. In fact, you see this, if you've ever seen like a bicycle with like a little. Ribbon at the end of one of the spokes. Like say you have like, this is a wheel here. And you have a little ribbon. Tied right there, there's a ribbon here. What motion does the ribbon make as the bike moves? As the wheel rolls forward, the position of the ribbon does some shit like this. It goes up when the wheel's over here, it's at the top. When the wheel's here, it's at the bottom again. And as it's going up, the wheel could be like right. It's probably like that. Over here, it's probably like that. What point is the ribbon making? That's called the cycloid. I don't know a lot of fucking uses for it, but I imagine that they'd use it for some shit. Some bridges might have this structure. You do see bridges where they have. Like there's like some shit like this. I don't know how that helps structurally, but that might be following a cycloid, I'm not sure. I'm gonna have to ask the engineering professor. I think like, doesn't like the Brooklyn Bridge or some shit like that look like that? I don't know, there's bridges that look like that. So the equation for a cycloid is parameterized. X equals AT minus A sine T. And Y equals A minus A cosine T. Where it looks like A is the amplitude. Where it gets to the top. Like the vertical height. We'll just look at a couple of the T's that are. Major here, like when T equals 0, what happens? X equals 0 minus. A times sine 0, which is 0. Sine 0 is 0, so that's all 0. And Y is gonna be. A minus A cosine 0. Which would just be A minus A, which is also 0. So T equals 0 is like where the. It starts with the ground. Dots on the ground. Or lowest point. Like I guess on a ribbon on a bicycle, it's not actually. At the ground, it's right above it. And if we did something like T equals pi over 2, what happens? X is. A times pi over 2 minus A sine pi over 2. Y equals. Pi over 2 minus. Nope, A. Minus A cosine pi over 2. This looks like A times pi over 2 minus A, or. A times pi over 2 minus 1. And Y cosine of pi over 2 is 0, so this just becomes A. Which is gonna be when it's at its top. Highest peak. if there's a homework problem on cycloids, I don't recall if there is. Treat it as extra credit. Don't do the cycloid problem, it's. Unless you want the challenger to practice working with parameters.
What is the word of the pilot to, that's just an example. That this is.
So like I was picking values for the T. That's gonna make these, the sine and cosine functions simple to look at. In reality, I would probably say 0, 1, 2, 3 because that's how I think of time. But now I got shitty fucking looking problems. You know what I mean? Sine of 3 is in like sine through radians. It's easy to forget that shit's in radians when you don't have the pi's in there. You might think sine 3 is sine of 3 degrees, and it's not. So like T is in radians, not degree.
Just for the second. And I guess earlier. They're just for the second.
In general. In all applications. You're better off using radians. For the parameter. In this case, T, but theta is also technically a parameter. For the, I'm gonna say for the parameter inside trig functions. Because sine of 3 is just a little less than sine of pi. Which would be like sine of 3.14. Well, I guess no, not a little less, a little more. Is, let's say is close. The 3 is in radians, not degrees. And it makes more sense when you see shit where the parameter is outside a trig function. I wouldn't say x has a position of a degrees when t equals 1. That makes sense. Like degrees is not it's not, like radians have no unit. Which is what's nice. A here has the units, like if A is in feet. The amplitude, A is amplitude. Probably why they gave it A. So it has the units. Whether it's in feet, meters, whatever, radians have no units. So like our position needs to be in terms of something that is only in units of this measurement. Degrees is not a distance. Just radians is in general better for all things. If you use radians all the time, the only time like it's not you, unless you're doing navigation on a fucking boat. You know what I mean? Or looking at like global positioning. Cause we like, when we look at a globe, we tend to be thinking latitude and longitude based on degrees. Alright. I started off saying how well we were gonna learn how fucking golf ball flies, right? So trajectory of an object in motion. Flying object. The parametric equations that govern this. Let's say V is velocity in feet per second. Or if you did it like that, you could write it like that. We need to have that. The equation is different. For different units. Equations are different in metric. And let's say theta is the angle with the ground. And we're gonna give it a like a starting height h. That angle there is theta. B is in that direction, it's like a vector, it starts. Back, we could do v of t. Is in that direction. The equations are x equals b cosine theta times t. And y equals negative 16t squared plus b sine theta times t plus h. If you do this in metric, x should still be the same, but this is negative 9.81 t squared. Because that coefficient is very much related to something specific. It's gravity. This value here is gravity in those different systems. Feet per second squared or meter per second squared. And I wrote it there, but I'll write it here, h is starting height. And the breakdown for why do they break down B? Let's say V is like that. The initial. I'm gonna say V0, the initial angle it's going, it's got a specific vector. As the ball's flying, like the vector where the velocity is going is changing. But so like it's the initial vector. Well, the x component, if we make a triangle, like here's x, here's y. There's my theta. But these are measured like in steps of t. X is a distance, b is a velocity. Like x is in feet, b is in feet per second. So b times t is feet per second times seconds, which is just feet. So like x is like bt here. Y equals VT, their vertical positions. And the way I got this set up makes this look funny. Because x over VT equals, if I grab this equation. Maybe I need to redraw my picture. X over VT equals cosine theta. So let's call this VT. V times T. There, now the picture matches. And y over VT equals sine theta. VT is a distance. As are x and y. So. Let's go back and pull those equations we had earlier. Or pull the question we had earlier. So I'm just gonna summarize the question that we had earlier, what we motivated this very topic with. We had angles 25 degrees, 45 degrees, 65 degrees. We had V was 120 feet per second. So effectively, we've got like the ball is launched low. That might be 25 degrees. 45 starts off like that, it's gonna do some shit like that. And 65 degrees has a higher angle. Tends to go up, probably go up higher. Do some shit like that. So I think this one's gonna travel the farthest. And I think that one is gonna travel the highest. I think. Find out which one travels the farthest. This is x, so we really only need to check x. What does x equal for each of those? X is b cosine t. Or cosine theta times t. Ooh. We gotta figure out when, how far it goes, we gotta figure out when it hits the ground. Don't we? We gotta kind of like solve the other one first. That doesn't help us because we need t for this. So let's take a look at y. Y equals negative 16t squared plus b sine t, sine theta t plus h. What's my h here? What was the starting height of the ball?
0.
0. We said we hit it from the tee, we usually set the ground equal to 0. So h equals 0. That's nice. That's gone. What is y when the ball hits the ground? 0. When it hits the ground, y is 0 also. So this turns into 0 equals negative 16t squared plus b sine theta t. If I factor that, I get t times negative 16t plus b sine theta. So it hits the ground, it's at ground level when t equals 0 or when this equals 0. I'm gonna do the generic formula first, because then we can just plug in the theta for each of the individual ones and find that shit out. So or negative 16t plus b sine theta equals 0. I subtract V sine theta from both sides. And then divide by -16. And we get T equals V sine theta over 16. That actually makes this pretty handy, because then I can do that little TXY table thing that we did before. Let's say this one is for the 25 degrees, 45 degrees. And 65 degrees. And we're gonna do 3 values for T. Fun fact, it hits the highest point at half the time. Makes sense. It's covered half the distance to get to the top, it's the other half is afterwards. So the highest point is at. When we do 1/2 that. 1/2 of T is 1/2 of V sine theta over 16. We gotta figure out what those values are. Let's clean that up a little bit. B was 120. What's 120 divided by 16? Something nice, excellent. 7.5 times sine theta. Which means the height. This is T at ground, when T hits the ground. And we're gonna have 3.75 sine theta for the height. So. We have values for each of these. We are gonna do, for this one here, we know 0 is 0, 0. What is 7.5 sine of 25 degrees? 7.5 times sine, I hope I'm in degrees, I am. I'm gonna say 3.17. And the other one we wanna look at is half that. 1.58. And we set that up for the other one, 7.5 times sine of 45. You got 5.3 and then divided by 2. Oop. About 2.65. And if I do 7.5 of 65 degrees. 6.8. And 3.4.
T0
Is when it's hitting the ground. So this should be a 0 on each of these. Cause that's the time when it's hitting the ground. Apparently, if we plug that in, we solve for this. We can plug it in and check it out. My y, this is my equation up here for y.
7.5.
I divided b as 120.
That's the one.
B was the given to us initially. Good question. Where did David get all this shit? If you don't know where it's coming from, you're like, this is just fucking making shit up. And this is shifty. So for each of those, it should be 0. So it looks like the 65 degrees has the longest hang time. It's in the air the longest. Right? These are in seconds. These are when it hits the ground. It's in the air the longest at that. Now we gotta find the other values. X equals V cosine T. So. Like, for this one, we're doing X equals 120. Cosine 25 degrees times T. To find these values. 120 times cosine of 25. I'm gonna have 108.75 times T. So let's see, let's say 757. So 108.757 times 3.17. This one traveled 344.76 feet. Here we've got 120 times cosine 45t. I'm off screen. So X here is 84.853 times t. And I'll multiply that by 5.3. And I get 449.7 feet. And then if I do this one, I've got 120 cosine of 365, or not 365, 65t. What is 120 of cosine times cosine 65? This is a really low value, 50.714 t. But what I'm doing here to get this is I'm just taking this value, the 3.17, the 5.3, and the 6.8, and just plugging it in for the t. It's giving me my x position. 344.8. So apparently this one goes the farthest. Farthest. I guess my picture doesn't look right. I was wrong. My guess here, I thought the 25 degrees would go the farthest. I guess it's just not in the air, like it's such a shallow thing that gravity pulls it down too quick, it's gonna travel. That's far. We don't really, like, this isn't really relevant for what we're looking for on the height, so let's just figure y here. And the y value is this equation right here. We set y equal to 0 to find the ground hits the ground. But the actual equation for y is that. That's what we need to plug in using each of these values for t. So let me put this on another picture. So for 25 degrees, y is negative 16 times 3.17 squared plus 120 times sine of 25 degrees times 3.17. This is not gonna be fun calculator work. But I'm writing out all of these right now real quick. After this, it's just a calculator grind. When you take physics, you will spend more than 30 minutes on this topic. This feels like a rush job, but it, cause it kind of is, we're just introducing an application of parameters. As you go in physics, like. Physics 55 is on kinematics, there's like several weeks on travel, motion. I'm sure that they probably spend a week on flight alone. Flight of an object under gravity. So let's see, we got -16 times 3.17 squared. Plus 120 times sine 25 times 3.17. That can't possibly. Right, how do I get a negative value? Oh. Fuck. I used the wrong keys. Your scrub teacher's grabbing from the wrong line. I'm grabbing for when they hit the ground. So they're all gonna be really close to zero if you do the other ones. Which sucks, cause that took a while to type in, didn't it? You're like, God damn it, Jones, get your shit together. So the height I'm getting on this one is about 40.2 feet. You're hitting at a low angle, it shouldn't go up very high, that kind of makes sense. This one, I'm getting Y is 112.5 feet. And this one, I'm getting Y equals 184.8 feet. So if I were to kind of like map these all on the same thing. It looks like the 25 degrees. And 65 degrees actually hit about the same X distance. And the 45 degrees goes farther. Interesting. When you take in calculus 1 and then do physics 55, you will find the optimal angle to hit the ball out to get it to go the furthest. Now, doing that as a golfer is not fucking easy. Like knowing the angle to hit it at and doing it are two different fucking things. But there is an optimal angle to hit it at to get the distance. And calculus will show you that. Alright, that's it. That's all we got for this semester. We're gonna do the practice test on Thursday and finals next Tuesday. Fuck yeah, party on. Are we not excited?